Dairy factories are specialized facilities that process raw milk into a variety of dairy products, such as milk, cheese, butter, and yogurt. Here's a breakdown of the main steps involved in this process. 1. Collection and reception of milk. The milk is typically sourced from dairy farms and transported to the dairy factory in refrigerated tankers to maintain freshness. Upon arrival, the milk is tested for quality, including checking for contaminants, fat content, and bacteria. 2. Pasteurization. Pasteurization is a heat treatment process that kills harmful bacteria and pathogens without compromising the taste or nutritional value of the milk. The milk is heated to a specific temperature, typically around 161 degrees Fahrenheit or 72 degrees Celsius, for about 15 to 20 seconds, then rapidly cooled. This ensures the milk is safe for consumption and extends its shelf life. 3. Separation and standardization. After pasteurization, the milk is separated into cream and skim milk using a centrifuge. This step allows the factory to standardize the milk's fat content, depending on the type of product being produced. For example, whole milk might have a higher fat content, while skim milk has little to no fat. For fermentation for cheese and yogurt. Cheese. To make cheese, the milk is first acidified, usually with lactic acid bacteria, which lowers the pH of the milk. This helps the milk proteins, mainly casein, to coagulate. Rennet, an enzyme, is then added to further help coagulate the milk, turning it into curds and whey. The curds are cut, cooked, and stirred to release more whey. Afterward, the curds are drained and pressed to form cheese. Yogurt. To make yogurt, specific bacterial cultures such as Lactobacillus bulgaricus and Streptococcus thermophilus are added to the milk. These cultures ferment the lactose milk sugar into lactic acid, which gives yogurt its characteristic tangy taste. The milk is incubated at a warm temperature to allow fermentation to occur. 5. Aging for cheese. Some types of cheese, like cheddar or Gouda, require aging to develop their flavor and texture. After the curds are pressed and formed, the cheese is stored in a controlled environment, often a cool cellar, for several weeks or months, depending on the desired characteristics of the cheese. During this period, the cheese develops its distinctive flavor, and moisture content decreases. 6. Processing for butter. Butter is made by churning cream, which is separated from the milk. Churning agitates the cream, causing the fat globules to clump together and separate from the liquid. Buttermilk. The solid fat is then kneaded, washed, and sometimes salted to produce the final butter product. 7. Packaging. After the dairy products are processed, they are packaged into various forms for distribution. Milk is typically bottled or cartonized, while cheese is wrapped in plastic or wax, and sometimes vacuums. Butter is often packaged in sticks or tubs, and yogurt is commonly sold in individual cups or large containers. 8. Quality control. Throughout the entire process, quality control is crucial to ensure that the final products meet health and safety standards. This includes testing for consistency, taste, texture, and microbiological safety. 9. Storage and distribution. Once packaged, the products are stored in refrigerated warehouses and distributed to retailers, grocery stores, and other outlets for sale to consumers. 10. Homogenization. After pasteurization, milk is often homogenized to ensure the even distribution of fat throughout the liquid. Homogenization breaks down the fat molecules in the milk into smaller sizes, preventing the cream from separating and rising to the top. This creates a smooth and uniform texture. This is particularly important in milk production, as it ensures that consumers get a consistent product every time they open a carton. Different types of cheese production. Fresh cheese. Cheese like ricotta, cream cheese, or mozzarella can be made without aging. After curdling, the curds are drained and packaged. Fresh cheeses tend to have a high moisture content and a mild flavor. Hard cheese. These are cheeses that undergo longer fermentation and aging, such as Parmesan and Gouda. After curds are formed and drained, the cheese is pressed to remove excess moisture, then stored in special environments to age and develop more complex flavors. Soft cheese. Cheese like brie or camembert undergoes a specific aging process that promotes the development of a creamy interior with a soft rind. These cheeses may be inoculated with specific molds or bacteria to create unique flavors and textures. Each cheese type might also undergo different steps, like washing the curd to reduce acidity, brining, salting in brine, or pressing at different pressures to control moisture content and texture. 12. Fermentation process in yogurt production. Cultures and fermentation time. The fermentation process in yogurt is a delicate balance of time and temperature. Yogurt cultures, the specific bacterial strains, are added to pasteurized milk that has cooled to about 110 degrees Fahrenheit, 43 degrees Celsius. The cultures start fermenting the lactose into lactic acid. The process typically lasts between 4 to 12 hours depending on the desired thickness and tanginess. The yogurt thickens as the bacteria work, and the acidity increases, which gives it its characteristic flavor. Flavored yogurts and additives. In addition to plain yogurt, flavored yogurts are produced by adding fruit purees, sweeteners, and flavorings to the base yogurt. Some dairy factories also add thickeners like gelatin or pectin to create creamier textures or enhance stability. 13. Butter production. Detailed steps. Cream separation. To produce butter, the cream is first separated from the milk. The cream can be pasteurized before being churned, although some traditional butters use raw cream. The fat content of the cream, typically 35 to 40%, is key to producing butter with the right texture. Churning. Churning involves agitating the cream until the fat molecules clump together, and the buttermilk, the liquid byproduct, separates from the butter. This process can be done by hand or using mechanical washing after the butter is formed. It's usually washed with cold water to remove any remaining buttermilk, which helps preserve the butter for a longer shelf life. Salting optional. Some butter is salted to enhance flavor and prolong shelf life, while unsalted butter retains a more neutral taste. 14. Cheese aging. Detailed process. Conditions for aging. Different cheeses require different aging conditions. Some need cool, damp environments, while others are aged in more arid conditions. The relative humidity, temperature, and airflow all play crucial roles in the aging process. Aging periods range from a few weeks for soft cheeses like camembert, to several months for harder cheeses like cheddar or Gouda. Mold-driven cheeses. Some cheeses, like blue cheese or brie, develop distinctive molds that are either introduced during the cheese-making process or form naturally as the cheese ages. These molds contribute to the texture and flavor development of the cheese. Rind development. Rind formation is another critical aspect of cheese aging. Some cheeses develop a natural rind, while others may be coated with wax, oil, or salt to prevent moisture loss and promote aging. The rind helps protect the cheese from harmful bacteria and controls the aging environment. 15. Byproducts of dairy processing. During the various processes in dairy production, several byproducts are created. Whey. This is the liquid that remains after the curds are removed during cheesemaking. Whey can be used in a variety of ways, including in protein powders, beverages, and even in animal feed. Whey is rich in protein and other nutrients, so its management is important in sustainable dairy processing. Buttermilk. The liquid left over after butter is churned. It's often used in baking or as a base for some beverages. It's low in fat but contains proteins and lactose. Cream. The cream separated from milk during the pasteurization process can be used to make a wide variety of products beyond butter, such as sour cream, whipped cream, and heavy cream for cooking. 16. Packaging and preservation techniques. Vacuum sealing. For products like cheese and butter, vacuum sealing helps preserve the product's freshness by removing air that might cause spoilage. Modified atmosphere packaging map. This is a packaging technique where the atmosphere inside the packaging is altered to extend shelf life. For example, cheese might be packaged with reduced oxygen to slow the growth of mold. Frozen dairy products. Some dairy products, such as butter and some cheeses, may be frozen for storage or transportation. Yogurt is occasionally frozen to make frozen yogurt treats, with added sweeteners and flavorings. 17. Sustainability in dairy factories. In recent years, there has been an increased focus on making dairy production more sustainable. Energy efficiency. Modern dairy factories are looking into energy-saving technologies to reduce power consumption. Some use renewable energy sources, such as solar or wind power. Waste management. Efficient waste. Management systems are in place to handle liquid waste, such as whey and wastewater, and solid waste like packaging materials. Some factories even recycle byproducts into animal feed or bioenergy. Sustainable packaging. Many dairy producers are moving towards eco-friendly packaging solutions, such as biodegradable containers or recyclable materials, to reduce environmental impact. 18. Health and safety standards. Dairy factories must adhere to stringent health and safety standards. Regulations vary by country but generally involve HACCP hazard analysis critical control points, a system used to identify potential hazards in food production and put controls in place to prevent contamination. Sanitation. All equipment, surfaces, and employees must follow strict hygiene practices to prevent contamination. Dairy production is sensitive to bacteria like Salmonella, Listeria, and E. coli, so sanitation is critical. 19. Advanced techniques in milk processing. Microfiltration. This is an advanced filtration technique used to separate bacteria and suspended solids from milk without the need for heat. It's often used in conjunction with pasteurization to provide a higher quality product, particularly for premium milk and yogurt. Microfiltration can extend shelf life and improve the taste by retaining beneficial components like proteins and enzymes that may otherwise be damaged by traditional pasteurization. Ultrafiltration UF. This is another filtration method where milk is forced through a semi-permeable membrane to separate smaller molecules, like lactose and minerals from larger molecules like proteins and fats. This method is used in the production of ultrafiltered milk, which is thicker and has higher protein content, catering to specific markets, such as fitness-focused consumers. Reverse osmosis Hondonia. Reverse osmosis can concentrate milk, or separate water from milk, to produce products like condensed milk, or to remove water to enhance flavor in certain cheeses. RO is especially useful in producing milk powders for both domestic and industrial use. 20. Automation and robotics in dairy factories. Automated milk collection systems. In modern dairy factories, milk collection is becoming increasingly automated. This includes using robotic systems to monitor milk quality, ensure precise collection, and control the flow to reduce human error and increase efficiency. Sensors also help monitor temperature, composition, and other factors critical to the processing stages. Robotic cheese pressing. For cheese production, robotic systems are often employed to press curds into molds with uniform pressure, ensuring consistency in cheese texture. These systems are increasingly sophisticated, capable of adjusting pressure dynamically based on the moisture content of the curds. Packaging robotics. Automated packaging lines use robots for filling, sealing, and labeling dairy products in various packaging types such as bottles, cups, and tubs. Robotics ensures high-speed error-free packaging, reducing labor costs and increasing throughput. 21. Enzyme-driven dairy innovations. Enzyme coagulation in cheese production. Beyond RIT, modern dairy factories are utilizing specific enzymes like lipases and proteases to create specialty cheeses with unique textures, flavors, and even nutritional benefits. For example, lipase can create more intense flavors in cheeses like Romano, while enzymes that break down proteins can soften cheeses like brie. Lactase for lactase-free products. Enzyme lactase is added to milk to break down lactose for those who are lactose intolerant. This allows producers to offer lactose-free versions of milk, cheese, and yogurt. It is also used in lactose-free ice cream and dairy-based beverages, making dairy accessible to a larger segment of consumers. 22. Probiotic cultures and functional dairy products. Probiotic yogurt and dairy beverages. Advances in fermentation have led to the rise of probiotic dairy products. These include yogurts and drinks enriched with live bacteria that offer digestive and immune health benefits. Strains like Lactobacillus, Acidophilus, and Bifidobacterium bifidum are often used for their potential health-promoting properties. Some products may also contain additional prebiotics, fiber, or other bioactive ingredients. Functional cheese. Similar to probiotics in yogurt, functional cheeses are being developed with added health benefits, such as lower sodium levels, higher calcium, or additional vitamins. These cheeses might also be fortified with omega-3 fatty acids from added fish oil or plant-based sources. 23. Milk and dairy powder. Production. Spray drying for milk powder. To produce milk powder, milk is typically concentrated using evaporation, followed by spray drying. This process involves spraying the concentrated milk into a hot air chamber, where the water evaporates quickly, leaving behind fine milk powder. This method is widely used for producing products like infant formula, bakery ingredients, and protein powders. Roller drying for milk powder. Another method of drying milk is roller drying, where milk is spread onto large heated rollers. As the milk dries, it forms a thin layer that is scraped off as a powder. This method produces a more granular texture compared to spray-dried powder. Milk protein concentrates MPCs and isolates MPs. These are produced by ultrafiltration and are highly concentrated sources of milk protein. They are used in various food products such as sports nutrition, protein bars, and even as additives in other dairy products to boost protein content. 24. Sustainability innovations in dairy production. Dairy production is becoming increasingly focused on sustainability. Key innovations include green energy usage. Many dairy factories are adopting renewable energy sources such as wind, solar, and biogas. Biogas is particularly relevant in dairy production, as it can be generated from organic waste such as manure, which can be used to power the factory. Water conservation. Dairy production is water-intensive, so factories are investing in water-saving technologies. Closed-loop water systems, which recycle and purify water used in processing, are becoming more common. Additionally, some dairies use rainwater harvesting to supplement their water needs. Zero-waste initiatives. Many dairy companies are adopting zero-waste strategies, where every part of the raw material milk is utilized. Byproducts like whey and buttermilk are used to produce value-added products, such as whey protein or as animal feed, rather than discarded. Carbon footprint reduction. Some dairy producers are using carbon capture technologies to minimize the greenhouse gases emitted during processing. For example, capturing CO2 from fermentation tanks or burning it to generate energy. 25. Global dairy trends in customization. Plant-based alternatives. The rise of plant-based diets has also led to a surge in plant-based dairy alternatives, such as almond milk, oat milk, and coconut milk. Many dairy factories now have dedicated lines for producing these non-dairy products. These alternatives are designed to mimic the texture, flavor, and functionality of traditional dairy products, while offering options for vegans, lactose-intolerant individuals, and those with allergies to cow's milk. Customization of flavors. With growing consumer demand for customization, some dairy manufacturers are using advanced flavoring technologies to offer unique cheese and yogurt flavors. From exotic herbs and spices to regional fruits, dairy factories are exploring novel ways to create distinctive flavors to appeal to niche markets. 26. Advanced testing and quality control. Spectroscopy and rapid testing. Modern dairy factories are employing advanced spectroscopic methods such as NIR or near-infrared spectroscopy to analyze the chemical composition of milk, including fat, protein, and lactose content. This allows for better quality control and ensures that products meet the required standards, without the need for lengthy traditional testing methods. Microbiological monitoring. Automation and real-time microbiological testing are helping to monitor and prevent contamination in dairy products. The use of advanced sensors and automated systems enables faster detection of harmful bacteria, reducing the risk of spoilage or health hazards in the final product. 27. Traceability and transparency. Blockchain for traceability. In response to consumer demand for transparency, some dairy factories are using blockchain technology to track and verify the origin of milk and dairy products. Blockchain allows consumers to trace the journey of their product from farm to table, ensuring that it meets ethical and quality standards. Ethical sourcing and animal welfare. With an increased focus on animal welfare, dairy producers are ensuring that their supply chains follow ethical practices. This includes ensuring that cows are treated humanely, provided with high-quality feed, and live in environments that support their natural behaviors. 28. Precision fermentation and microbial cultures. Precision fermentation. This cutting-edge technology involves the use of genetically engineered microorganisms to produce dairy proteins like casein and whey, without the need for cows. Precision fermentation enables the creation of dairy alternatives that mimic traditional dairy products but are completely animal. Companies are using this technique to make plant-based cheese and milk that contain the same proteins as their animal-derived counterparts, making them suitable for those who avoid dairy for ethical or environmental reasons. Microbial cultures for flavor development. In cheesemaking, traditional microbial cultures, lactic acid, bacteria, molds, and yeasts are key to flavor and texture development. Modern biotechnology is expanding the use of specific strains of bacteria to develop unique, complex flavors. For example, certain probiotic bacteria can enhance the flavor profile of yogurt or kefir, creating tangier, more complex varieties. 29. Smart dairy farming IoT and AI Internet of Things IoT in dairy farms. The advent of IoT is transforming dairy farming by enabling real-time monitoring of cows' health, milk production, and environmental conditions. Sensors placed on cows or in barns can track their temperature, activity, and even rumination chewing, providing farmers with valuable data to optimize production and ensure animal welfare. AI for milk quality and yield optimization. Artificial intelligence, AI, is being applied in dairy farms to predict milk yield, detect diseases in cows, and identify optimal feeding strategies. AI-powered systems can analyze data collected from sensors, including environmental factors, cow behavior, and genetics, to make real-time adjustments that maximize milk production and quality. Robotic milking systems. Robotic milkers are becoming increasingly popular on dairy farms, particularly in Europe and North America. These systems allow cows to be milked automatically whenever they choose, reducing the labor needed for milking and increasing milking efficiency. Robotic milking also allows for more precise control of milk collection, reducing stress for cows and improving milk quality. 30. Dairy-based ingredients for food processing. Whey protein isolate WPI. Whey protein isolate, a byproduct of cheese making, is widely used in the food industry, particularly in protein supplements, energy bars, and ready-to-drink shakes. Whey protein is highly digestible and has all the essential amino acids, making it ideal for athletes and health-conscious consumers. It's also used in bakery products to improve texture and nutritional content. Milk powder as an ingredient. Milk powder, especially skim milk powder SMP, and whole milk powder WMP, is a vital ingredient in the production of infant formula, confectionery, and bakery products. The drying process used to make milk powder concentrates the nutrients, making it easier to transport and store, and it retains the nutritional profile of fresh milk while extending its shelf life. 31. Dairy in functional foods and beverages. Dairy as a source of bioactive compounds. The dairy industry is increasingly focused on incorporating bioactive compounds like peptides, antioxidants, and conjugated linoleic acid, CLA, into functional foods. These compounds are believed to offer health benefits, such as improving heart health, reducing inflammation, and enhancing immune function. Fortified dairy products. Dairy products are being fortified with vitamins and minerals to cater to specific health needs. For example, some brands add vitamin D to milk to help with calcium absorption, or they fortify yogurt with additional probiotics for digestive health. Dairy-based drinks enriched with vitamins, minerals, and fiber are also gaining popularity as convenient health-focused beverages. Plant-based dairy alternatives and blended products. In response to the growing plant-based movement, some dairy producers are blending plant-based ingredients, like almond, oat, or soy milk, with cow's milk to create hybrid products that offer the benefits of both worlds. These products often include dairy proteins for nutrition, while maintaining the flavor and texture of plant-based options. 32. Regional and niche dairy products. Artisanal cheeses. Small-scale, artisanal dairy producers are experiencing a renaissance globally. Many regions take pride in their unique varieties of cheese, which are produced using traditional methods passed down through generations. For example, Parmigiano Reggiano in Italy, Roquefort in France, and Manchego in Spain are made with regional milk and aged in specific conditions. Artisanal cheeses often come in smaller, handcrafted batches, focusing on quality and craftsmanship. Fermented dairy products in different cultures. While yogurt and kefir are commonly associated with dairy consumption, many cultures around the world have their own unique fermented dairy products. Kefir, Eastern Europe, Caucasus, a fermented milk drink. Kefir is rich in probiotics and often used for its gut health benefits. Lassi, India, a traditional yogurt-based drink, often flavored with fruits, spices, or herbs, offering both digestive benefits and hydration. Skyr, Iceland, a thick, creamy dairy product similar to yogurt, but with a milder flavor, often used as a snack or dessert. Clotted cream, UK, a rich, spreadable cream made by heating milk, popular in Devon and Cornwall, typically served with scones. 33. Milk alternatives and hybrid products. Hybrid plant-based dairy products. Many dairy companies are venturing into the plant-based market by blending plant-based milks with cow's milk. For example, Some companies are creating products that combine oat or almond milk with traditional cow's milk to cater to those who want to reduce their dairy intake, but still enjoy the flavor and texture of dairy. Functional plant-based milks. Many plant-based milks are now fortified with additional nutrients like calcium, vitamin D, and B12 to mimic the nutritional profile of cow's milk. For instance, oat milk is becoming a popular alternative for coffee drinkers because of its smooth texture and ability to froth. These milk alternatives also cater to individuals with lactose intolerance or dairy allergies. 34. Waste reduction and circular economy in dairy production. Circular economy in dairy factories. Circular economy and principles are being adopted by dairy producers to reduce waste and make the production process more sustainable. This includes recycling water, reusing whey and other byproducts for animal feed, bioenergy, or even cosmetics, and composting solid waste to create organic fertilizers. Zero-waste dairy products. Some producers are turning to zero-waste strategies by ensuring that every part of the dairy from milk to whey to butter and cheese byproducts is used effectively. For example, whey proteins are now used in skincare products, and spent grains from dairy feed are repurposed as animal feed or fertilizer. 35. Global dairy market trends. Growth in emerging markets. The global demand for dairy products is rising in developing regions such as Asia, Africa, and Latin America. As income levels increase and dietary habits evolve, people in these regions are consuming more dairy, leading to increased production and investment in local dairy industries. Ethical and sustainable sourcing. Consumers are more aware of the environmental and ethical implications of their food choices, prompting dairy producers to emphasize ethical sourcing. This includes implementing fair trade practices, supporting animal welfare, and reducing carbon footprints across the supply chain. Premium dairy products. The market for premium dairy products is expanding, especially in developed economies. Consumers are willing to pay more for higher quality products like organic, grass-fed, and antibiotic-free dairy, as well as products with added health benefits such as probiotics or omega-3 fatty acids.